Yes, sir. Here we go. Fantastic. Last section, last video for the semester. So exciting. Hopefully, you've enjoyed the videos and they are helping. And maybe you could give me some feedback. I think I might ask you in a formal, I don't know, evaluation of the video. So maybe get your thoughts together. Anyways, let's get going here. So we got section 6.6. This is called solve radical equations. A radical equation is an equation with a radical that has variables in the radicand. How do we solve them? 3 steps. We try to isolate the radical on one side of the equation, and then we raise to a power that eliminates the radical. So if you have the square root, we raise to the square power. We'll see that in a sec. And then step 3 is that we solve the polynomial equation using techniques you've learned in previous chapters. And then the big guy, and I think this really should get step 4 in my opinion, is to check your solution. Sometimes by squaring both sides of an equation, you will create answers that are incorrect. And so we have an example that will show that. So here you go. This is our example 1. We're doing 3 examples, and by far the easiest, but good way to get started. So first of all, it is a radical equation because of the square root radical, right? We can do third root radicals and different powered roots. And we'd like to solve for x. So the first thing we do is we square both sides of the equation. And we're doing that because, again, the square root is also to the power 1/2. 1/2 times 2 would eliminate it. Again, you guys should feel comfortable. Square root and square would cancel each other. But we have to do it to both sides of the equation. So we're left with x plus 6 equals 9, and then finally x equal to 3. And so that's your answer. Pretty straightforward. So go ahead and try one yourself. Again, this is a little bit harder in the sense you've got this plus 1, so you do not want to raise both sides to the power to eliminate the radical. So why don't you isolate the radical, maybe subtract 1 from both sides, and then figure out what power you need to raise both sides of the equation to eliminate this third root. Go ahead and hit pause, and when you're ready, hit play. And here you go. The final answer should be -3. How did I do it? Well, first of all, I subtracted 1 from both sides. I got -2. And now realize maybe this helps you to see that the third root written in the the cool radical symbol is the same as raise to the power 1/3. To eliminate 1/3, I need to multiply by 3. I need to raise both sides to the power 3. And then these guys cancel to 1, and you're left with x minus 5, and -2 raised to the power 3 is -8. Last step, add 5, and I've got the final answer. Well done. Example 2. So here you go. This is, the third root and also squared. So when we solve this, and what we're trying to do here is to get, and I'm sorry about the way this is written, but this is 2/3 times 3/2. And that will equal 1. So again, you always multiply by basically the reciprocal. 16 raised to the 3/2. Can you do that in your head? This means the square root of 16, which is 4. 4 raised to the power 3 is 64. Awesome. And we subtract 4, divide by 3, we get 20. And we can plug this back into the original and see that it does indeed work. So here we go. Big example 3. Gotta stretch it out. Example 3. So here we go. We're given a radical. It's definitely a radical equation. The radical is isolated, right? If this had been, the plus 2, we'd move the 2 over. Again, we just want to get the radical by itself. So our first step, hopefully you're screaming in the computer, hey, we're going to square both sides. And that is indeed correct. Be careful here. X minus 2 quantity squared is x squared minus 4x plus 4. Don't forget there's that middle term. And very nice here on the right side, which looks like the harder, just the radical, the square root and the square cancel, you're left with x plus 10. Hey, what kind of equation do we have now? That is correct. We have a quadratic equation, so we should set it equal to 0. And then look at that. It factors. Wonderful. If it didn't factor, we'd use the quadratic formula, and you have your program in your calculator. Excuse me, very rude, but I needed a little sip of tea. I set each factor equal to 0 and solve. And lo and behold, I have 2 answers. Well, unfortunately, one of these answers does not work. And you might just take a look and say, 6, it doesn't look so obvious. I mean, well, 6 you could plug in. 6 minus 2 is 4, and 6 plus 10, the square root, is also 4. So that does check out. But look at what happens with negative 2. Right? If you put negative 2 in here, negative 2 minus 2 is negative 3. And hey, you're done, right? There's no way you can take a square root and get a negative answer, right? Again, nice to be working with the range of the radicals so often, right? And here it says, they did it, they actually plugged it in, but again, it's crazy. There's no way that the square root of any number is coming out to be negative, much less negative 3. So you cannot circle this answer. So be very careful. Like here, you should be feeling, super proud of yourself. Hey, look at all the work I've done so far. I have 2 answers, and most people stop and say, like, great, I'm really psyched. Again, when you square both sides of the equation, this side doesn't care. That negative 3 turns to positive 9, and it doesn't care anymore that this side was negative. So you have to check, and then please do not circle both answers. 2 examples. So go ahead and do example 2 here. Looks like you should definitely do maybe 2 algebra steps before you isolate the variable, and then I would raise to the power to eliminate the 4/3. And then this second one that you're going to do, you're going to square both sides, and I can tell you right now, you better check your answers, right? Hit pause, and when you're here ready, I'll show you the answers. Excellent. The answer for problem 2 is 8. So here are my steps. I added 21 to both sides. I got negative 32. I divided by negative 2 and got 16. Again, if I'm raised to the 4/3 to cancel that, I need to raise to the 3/4. 16 raised to the 3/4. Thank goodness I can do that in my head, right? 16, the 4th root of 16 is 2. 2, right? And I wrote it this way just in case you wanted to see it, that cool radical symbol. This would just be 2. And 2 to the 3rd is equal to 8. And that is the final answer. Nice job. And finally, the big dog, right? This is the big problem that is the hardest problem of this section. So really give it your best. You want to square both sides. And again, the right side looks much harder, but it's actually quite nice because the radical squared, they cancel each other. Look at the left side. Again, we're going to square. We're going to never forget that middle term, right? We're really concerned about that. And then you should say, hey, I'm good here, right? I've got a quadratic equation. I know how to solve these. I set equal to 0. This guy factors again. I got my 2 answers. Looks awesome, right? Circle these. Must be right. But you need to check, because check it out. When you put negative 3 into the original equation, back here, not in the squared equation, but in the equation you were asked to solve, negative 3 plus 2 is negative 1. And there's no way that negative 1 is ever coming out of radical. So this answer is wrong. And you can have to cross it off. 1 does work, right? If you plug 1 in, you get 3 for the left side. Plug 1 in, you get square root of 9, which is 3, and you're done. Hey, well done. I look forward to seeing you on Monday. Again, last video of the semester, so pretty exciting. Hopefully you enjoyed the videos and they did help.